So Nitin, you're the host and we are streaming live, so you can get started.
Okay, sir. Fine. Thank you. Okay. Good evening, everyone. We are supposed to start off with organic chemistry today. Okay. So, starting with the introduction, organic chemistry, basically what had happened is it had started and they had said what is the first scientist which came across with this is Berzelius. He said what is there is a vital force which is present only in the living organism, and what he said that organic chemistry basically is only based on what living things. Like living things, they have something in their body, they have some vital force. Vital force is something which is given by God, which is inbuilt, which is there, which cannot be made somewhere else. So according to that, the vital force theory is said that it can be only made by living organism. So this was the first person, Berzelius, who said that. But in 1828, scientist Holler did what is he said about this, that the organic compound can be synthesized in the laboratory, and he synthesized urea by taking ammonium cyanate. Formula for ammonium cyanate is NH4CNO. When he heated this, we got urea, which is NH2CONH2. So this was the first synthesized organic compound, but you can see this is using inorganic content. Properly next is Kolbe, which in 1845 synthesized the acetic acid, which was the first organic compound. So he was the first person to who was the first person? The first organic compound was given by Kolbe, but the first organic compound synthesized was with, it was who? It was Euler. Okay, if we want to write the reaction, what Kolbe had done is Kolbe had 2C, which was reacted with hydrogen gas. There was an electric arc passed through this mixture, which led to the formation of HC triple bond CH, which is nothing but acetylene. This acetylene was not known that time. Presently, we know the name, so we are writing it. This is acetylene. And in presence of dilute H2SO4, and HgSO4, what happens? It gets converted, it gets oxidized, and it gets converted to CH3CHO, which is acetaldehyde. And after this acetaldehyde, this was oxidized. There was an oxidation done for this. It was again oxidized. So oxidation of this again gave it had the formation of CH3COH, which is acetic acid. So this was how this was the first organic compound which was synthesized in the laboratory by Kolbe. So this is basically is inorganic, using inorganic substance. This is ammonium cyanate, and this further, when you are moving further, this is what this is. Acetic acid was organic compound which was synthesized by Kolbe. Then again, Berthelot, he came with methane. So that all is not that thing. They will ask you which is the first synthesized compound. So it can be ammonium cyanate and it can be acetic acid, both. But first organic compound which was synthesized was this, because this is an inorganic compound, NH2CONH2. Okay, this is an inorganic compound. Okay, urea, that one. Moving to next one, you have few characteristic of organic compound. Now, if you see, organic compound is basically made out of carbon. The carbon is what? It's a group 14 element. If you write the electronic configuration for this, it will be written as 1s2, 2s2, 2p2. So now what is there is it have 4 outermost shell electron. This will be written as 2, 4. So it have 4 outermost electron, that is valence electron. So it normally what to make its octet complete, it have only one option, that it will try to share the electron. So if try to share 4 electrons, so it have option of completing its octet. So because of that, normally what happens, being the organic compound is basically compounds of what? It is basic compounds of, say we are written here is basic compound of carbon, hydrogen and oxygen. But there are few things like halogen is also present, nitrogen is also present, and even in some cases you can find phosphorus. So majority is what? Carbon, hydrogen and oxygen. So if you talk about this property of carbon, so carbon have 2 things, which one is tetravalency. Tetravalency is basically having 4 valency, and the second one is catenation. The catenation is what? Catenation is self-linking property of carbon. It can link to carbon atom and can build huge chains, branch chain or straight chain, and it can lead to the formation of big molecular mass compounds. So organic compounds, because they are covalent in nature, they don't dissolve in water because water is in polar solvent, but they dissolve in organic solvent. Like organic solvents are normally non-polar solvents, such as ether is there, alcohol is there, benzene is there. Due to maximum catenation basically is again 4 forming bond, tetravalency of carbon, they have tendency to form long open closed chain compounds. So it can form closed chain, it can form open chain. What is closed chain, what is open chain, we'll go and we'll study later. They are volatile, they are very impure, inflammable, catch fire, possess low boiling point or melting point. Because they have low melting and boiling point, obviously they'll catch fire faster compared to others. Some organic compounds, they exhibit phenomena of polymerization, that is ethene will be polymerized to polyethene. They exhibit isomerism, we'll study isomerism. We have stereoisomerism is there and geometrical isomerism is there. Stereoisomerism is there and second one is geometrical isomer is there. Okay, so we have to study stereoisomer for you. We are supposed to study stereoisomerism. We will do it later in the coming classes. They contribute to homologous series. What is homologous series? We'll study in today's class. They are non-conductors of electricity. They are covalent compounds. Obviously, being a covalent compound, they will be non-conductor of electricity. Organic compound include complex structures and high molecular weights because of catenation property. Okay. These compounds are combustible in nature. They all combine with oxygen. Excess oxygen will lead to the formation of CO2 and H2 as the final product. If it is not there, proper combustion is not there, then it will lead to the formation of CO and H2, carbon monoxide and water. Proper combustion is there, then it will lead to the formation of carbon dioxide and water. Most properties of compound are decided by functional group attached to them. We'll study those functional groups are what, like acidic is there, sulfonic acid is there, nitro group is there, halo group is there. So based on them, the properties of the compounds also change. Chemical reactions involving organic compounds proceed at a slower rate because they're very unreactive. In few cases where you'll have pi bonds, they'll be reactive, but then when they'll not have pi bonds with the mix, they'll not have pi electron. In the case of carbon, it is very rare. So that's why they'll mostly proceed in a very slow manner. Okay, next when we are talking about is method of purification of compound. See, organic compounds purification methods are there: sublimation, crystallization, distillation, differential extraction, and chromatography. This all is there. You have to know that basically what is the principle behind sublimation. They're not going to ask you what is the experiment, what is this thing, what is other. Sublimation is basically what is, you're trying to sublime something from solid to gas. So that is what that process from when you're trying to convert something from solid to gas, that is known as sublimation. So sublimation basically, sublimation will start happening for those things can be converted directly from solid to gas. So it's a process which solid directly changes to gaseous form. On heating and on cooling, gaseous state convert into solid state. The idea behind using this technique is to separate substance that show sublimation from substance that do not sublime. So you have to take two things. So I have A and B. So among this, say if this shows sublimation and this doesn't show sublimation. So those compounds I'll take, if I have to separate something, so I'll use I know that this particular compound can sublimate. So for this particular compound which can sublime, I'll use that, and something which is not able to sublime, so both of them will be used. So one will sublime, other will not, so you can be able to separate it. Crystallization, this method is based on what? It is based on the solubility of compound and the impurities in the suitable solvent. So this is basically solubility of the compound. So one particular solvent, so you took X solvent, in X solvent A is getting dissolved, but B is not getting dissolved. So what happens? So this will get dissolved and this will stay in the particular solution. Later on, by some method like evaporation or decantation or sedimentation, we can take out this A from this X. So what is that? Principles I'm telling. So this is the first principle for the sublimation process. This is what is the principle. Here the principle is solubility of the compound and impurities of the suitable solvent. Okay. Right, so this is what is the process. Impure compound will be dissolved in the solvent, and which is not fully soluble at room temperature, but once you increase the temperature, it'll start getting soluble, and this solution will get this till the solution becomes saturated. This reaction will go on, and after, when you're cooling this thing, the solution will become pure compound, as it will become crystallized, and you can remove that using filtration. But they are not going to ask you to write the method, because you're not having a subjective answer. What you have to know is you just have to know what principle behind this. Okay. Next is distillation process. Again, distillation, this method is used to separate volatile liquids from non-volatile impurities. So those things which are more volatile, the more impurities are there, and something which have less impurities, we are trying to separate them. And also in this, what we try to do based on what we try to do is based on their boiling point. Okay, so the third principle for distillation, the principle is what? Volatile liquids and non-volatile liquids, you are trying to separate based on what? Their boiling point. Okay, distillation is that process. Now coming to fractional distillation, this method is used for liquids which have nearly same boiling point. Now they don't have the boiling point difference. Okay, so they have this almost same boiling point. So therefore liquids, for both liquids condense and form at the same time. So it's very hard to separate them. So what we do in this technique is vapor of liquid mixture are passed through a fractionating column before condensation, and this fractionating column is fitted over a round bottom mask. So basically what they'll do, they'll try to say, if I have a mask over here, this flask is there, and this flask is basically being opened into, because of corona, so everywhere mask and mask. So basically what is happening is, because of the flask, the round bottom flask, this what they'll do, they'll take a tube. The tube will be kept in a tilted manner, and so from here they'll try to evaporate the mixture, which gets evaporated faster. What they'll do, so the thing which is less volatile with the thing, so we have two things, one is more volatile, one is less volatile. Which is more volatile will get evaporated faster, and it gets evaporated faster, and it will come here in the form of vapor, and then it will be allowed to come in this, and then through water, they will throw this water spray over here, and it will be cooled. So this is how they'll be collecting it. Okay, so based now for fractional distillation, what is the thing? For fractional distillation, they are using two impurities which have almost nearly same boiling point. Steam distillation, again, instead of using other fractional distillation, what we are doing, steam distillation, what we do is we are trying to separate substances which are steam volatile and immiscible in water. Okay, those things which are steam volatile, they are reacting towards steam, and they are not miscible, they don't mix into water. So for these things we use steam distillation. Again, same, you have differential extraction is there, which is again, now when an organic compound is present in the aqueous medium, then it is separated by shaking it with an organic solvent in which it is more soluble than water. Okay, This is what, so there is an organic compound which is present in aqueous medium. Aqueous medium is in water. So in water it is there. So what we do, we take that water and then we try to put it in a particular solvent, start shaking it, and the more, so what we have to make sure that it will be that solvent which we are using, it should be more soluble in that particular solvent compared to water. So it will get mixed, and once it is getting mixed, okay, so after that it can be removed using process of distillation or evaporation. Chromatography, this is a technique which is used to separate mixture in their components, purify, okay, compounds which can be solid or liquid, and also test the purity of compound. So what basically we do is, like, say there is a paper, and what we'll do is make different point over here, and this will be allowed, there will be a line made here, so that up to this level only you're supposed to dip it in that particular solvent, will make a liquid solution. And when you're trying to dip it, this will show this other color, this will show other color, and depending on the colors, so this particular will show this color, we can separate that. Yeah, at this region we have this particular compound, or at this region I have this particular compound. So this is how chromatography is used. Adsorption, you would have read, adsorption is what? Adsorption is something which, when some particles just stay on the surface of particular, like say if I'm talking about chalk. So if you're trying to dip a chalk into ink, if I'm taking a chalk and I'm trying to dip it into the ink, so when you're trying, later when you break it, you'll find that you don't find the ink inside everywhere, you just find that ink stays on the surface of the chalk. So when you're trying to dip something and it stays only up the, if you're trying to react something with something, it stays at the surface. So that is known as adsorption. When it is going inside in the bulk, that is known as absorption. Okay. Partition chromatography, two are things we can see here. Adsorption chromatography, it is based on the fact that different compounds are adsorbed on adsorbent at a different degree. So at different temperature, different things will get absorbed. So they'll get adsorbed and they'll be taking out. In this, what we use is adsorbent. So basically in adsorption, what happens? One thing is adsorbate, other is adsorbent. The adsorbent gets absorbed on adsorbent. So what we use, common adsorbent, we use silica gel or alumina. We'll try to use that, and most of the things get stick to that, and we'll try to separate it. Okay. Partition chromatography, it is based on the continuous differential partitioning of compounds of a mixture between stationary and mobile phases. There will be some phase which will be stationary, there will be some phase which will be moving, that is known as mobile phase. Okay, so this is just the basics, whatever you're supposed to know. Much questions you cannot expect from all that. What questions you will be getting now, from where you can get from organic compounds, will be this isomerism and their preparations basically. So we'll just try to focus on this. Okay, I have given you this thing, we have separate slides for everything. Okay, now what is there is organic compound. Broadly, what we try to say separate as open chain and cyclic. Okay, so now open chain, they'll have saturated basically means what? They'll have single bonds, and then can be unsaturated, that means they can have double bond, triple bonds and all. Okay, so let's see, then alkane is there which is containing single bond, alkene is there which will contain double bond, alkynes will come triple bond. So alkanes general formula is what? CnH2n plus 2, CnH2n, and this is what? CnH2n minus 2, where if you are substituting n value on this for this and all, this 2 you can substitute n value as 2 onwards, and n value 1 here it can be n equal to 1. Okay, and then it can go further. Okay. So let's starting with the first thing, the first so aliphatic or open chain compounds. So now if I'm talking about aliphatic or open chain compounds, so you can see that we can again classify them in the form of branched chain and unbranched chain. Okay, so these are, you don't have to read just don't read too much of theory, don't just see the examples. Aliphatic or open chain compounds, basically aliphatic means they'll be straight, or they'll be open chain, they'll not be branched there. So if something is cyclic, means where it is starting, there only they have to end.
But in this case is what, they'll not be cyclic. So we have two possibilities, they can be unbranched or branched. In this also we have two possibilities, same thing, saturated hydrocarbons, that is alkenes, and unsaturated hydrocarbons, that is alkene. For example, if I'm taking here, this is CH3, CH2, CH3. So this is what, this is propane. I'm taking propane, so you can see that propane, it have only, if I'm trying to write the structural formula for this, what I'll write, this will be CH3, and then I'll write what, this will be CH2, and this will be what, CH3. So this basically, if you see that everywhere, all the bonds, all the first bond which is formed between any compounds or elements, it will be sigma. So you can see all is only sigma bonds. So it doesn't have any pi bond. So when something doesn't have pi bond, it is comparatively less reactive. So that's why we write here that this is CnH2 and this is less reactive because of not presence of pi bond. And that's why their name is paraffins. That means param plus affine. Param affine means little reactivity. So because of unavailability of pi electrons, it is less reactive. Okay. Next, when we are talking about unsaturated hydrocarbons, they'll have double bond or they can have triple bond. So if they have double bond, that means they'll have 1 pi electron. If they have triple bond, that means they'll have 2 pi electron. Okay, so that's what is the thing. It goes in that way. If you have pi electrons, it will become more reactive. And what is there is they're known as olefins because they form oil forming compounds. They will form oily substances. Oily substances, they'll form unsaturated hydrocarbons when they combine with halogens. So when they combine with halogens, they're forming oily substances. So that's why they are also referred as olefins. So this is the first thing when we are discussing about your aliphatic. Next, we are supposed to go on which one? We have closed chain. Okay, closed chain. So next is what we are discussing is your closed chain. So closed chain is basically what, they'll be closed. They'll form a closed chain. So in this we have what? We have two things. One is homocyclic. Homocyclic means, homo word means what? They'll have only carbon atoms will be present in that thing. Like for this, if I'm trying to write, this is what? This is cyclopropane. If I'm writing for this thing, what, this is what? Cyclobutene. We'll see the nomenclature of all this. We have read it and we have it in very in depth for the slides. So don't worry. So what is that? Homocyclic is basically what? They'll have complete ring formed by carbon atoms only. In this also we have two things, which is alicyclic compounds or aromatic compounds. So alicyclic compounds, this compounds having properties like aliphatic compounds only. That is when it is open chain thing. This may be saturated or unsaturated. So this is saturated alicyclic compound, and this is what? This is unsaturated alicyclic compound. If I am right to see, this is written here. The name for this is cyclopropane. Cyclopropane. And this is what this is written as cyclobutane. So you can be saturated, having saturated, as well as you can have unsaturated. Aromatic compounds, well, this compound consists of at least one benzene ring. This is what is benzene. It will consist one benzene ring. After that, you can have anything else. They'll have some fragrant odor. That means they'll smell. They have a decent smell. Okay. Which use aromatic means, what aroma means? Sweet smell. Okay, so this is benzene. If you substitute CH3 on the benzene ring, is toluene. This is known as styrene. Still many is there. We have that naming also. If you're trying to attach on the benzene ring, you're trying to attach NH2. So name is aniline. If you're trying to attach SO3H, it is sulfonic acid. If you have NO2, it's nitrobenzene. So a lot of namings are there. So this is homocyclic, which will only contain what? Carbon atoms. So next is heterocyclic. It will contain what? This cyclic compounds having rings or rings built up more than one kind of atom. So you can see here, this is furan. It's here, it is carbon, 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 carbon. But what is present here is oxygen. Here also carbon, 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 carbon. What is present here is sulfur. So this is thiophene and furan. So this you can see, except carbon, they have what? Oxygen, furan, and thiophene have what? It has sulfur. You can write the organic compounds in two forms. One is structural formula, other is condensed formula. Structural formula, if you write it in this way, okay. We'll go to this. This is the structural formula, and if you want to write, basically, I'll just show you what is structural formula. This is structural formula. Where you try to write everything in expanded form. Like say, if I'm writing CH3, then I have CH2. Then I have Cl. So this is what full expanded form. So this is known as structural formula. The same thing I'll write it as CH3, CH2, Cl. This is condensed form. Same thing. No problem with this at all. Now we have to do classification of organic compounds. So classification of the carbon is done in the form of 1 degree, 2 degree, 3 degree, 4 degree, based on how many carbon it is attached to. Like for example, if I have CH4, so it is known as methane, or if I'm writing it as CH3, that is known as methyl. So there are many things, many books don't consider that as to be primary as well. For example, to this particular carbon, I have one more carbon attached. So this is 1 degree and this is 1 degree. Now what I'm doing is I'll attach one carbon to this like this. So now this becomes what? At present, this was 1 degree. Now in the same question, what I'll do is I'll do what is one, this thing. So now 1 carbon, 2 carbon. So now this became 2 degree. To the same carbon, now what I can do is one this side, other this side, this side. So now because 3 carbons are attached to this, directly they should be attached directly. When 1 carbon is attached to 1 carbon, that is 1 degree. If it attached to 2 carbon, it is 2 degree. If it attached to 3 carbon, it is 3 degree. And if I have to see that to the 3rd degree, how many hydrogen can be attached? Only 1 hydrogen. If it is 2 degree, how many H can be attached? 2 hydrogen. If it is 1 degree, 3 hydrogen I can attach, because total carbon need to have how many bonds? It can have only 4 bonds. So depending on how many are H, how many C are there, based on that I'll get H. So now if I have 1 degree primary carbon, so this is what is written here, 1 degree primary carbon, and the hydrogen present on primary, secondary and tertiary carbon will be said as primary, secondary and tertiary hydrogen. For a thing where a carbon which is attached to 4 carbons, which is known as quaternary carbon. So for quaternary carbon, there will be no H attached only, because already 4 bonds are over. So we don't have any 5th bond to attach hydrogen. Carbon can only have maximum 4 bonds. Okay, so you can see that here this we have written here. So because to this carbon only 1 carbon is attached, it is 1 degree. To this carbon, you see from this side 1 carbon is attached, from this side 1 carbon is attached, so it will be 2 degree. This one will be 2 degree. This is 1 degree. This is 2 degree. Now to this carbon, you see this side 1 carbon is attached, this side 1 carbon is attached, this side 1 carbon is attached. So this one is what? 3 degree. Because this is only attached to 1 carbon, this is 1 degree. See here, this carbon is attached to 1 carbon, 2 carbon, 3 carbon, 4 carbon. So this is why it is not the 4. quaternary carbon, and because this CH3 is again only attached to one carbon, so it is 1 degree. This is also attached to only one carbon, so 1 degree, and to 1 degree whichever height. So now this is 1 degree. Now this is 1 degree carbon. So to this CH3, how much hydrogens are attached? 3. So all these 3 will be what? Primary hydrogen. Okay, so this is how we classify this. Next is we have to deal with functional group. Functional group is an atom or group of atoms present in a molecule that gives the molecule its characteristic chemical property. Based on this only we decide the chemical properties of that compound. Okay, so these are all the names for them. Okay, this is carboxylic acid. This is sulfonic acid. This is acid. Basically, this is acid anhydride. What we do is say if you're, for example, if I'm taking two carboxylic acid. So I took COOH. So I took HCOH. This is methanoic acid. And what I did is I took CH3 COOH. I took acetic acid. So now I took this acetic acid. I'll try to write it in this way so that it will be more clear. I took acetic acid and methanoic acid. So what I did, I write it as OH. Then I have CH3 over here. So what we do is acetic and acid anhydride basically means what is from here water comes out. So what we do is we take this OH and hydrogen from here as an H2, it comes out. So what is left now on this, it comes as this. This is what is left. And here what is left is O. Then, so now you can see that this particular group is an anhydride. Because from this, what has happened from the combination of this two, water have been taken out. From this two group, I have taken out by combination of two carboxylic acid group. I took out H2O. H2O came out. So that's why this is acid anhydride. Because from this water have been taken out. So now this became what? An anhydride. Okay. Next is ester. Ester is all this thing where you are finding C double bond O, C double bond O. This is known as carbonyl. This is carbonyl. Okay. C double bond X is acyl halide. Amide is there. Cyanide is there. C double bond N. This is isocyanide, and when it forms, when the donation is from the C side, it is cyanide. When it is donation of electrons from the N side, it is isocyanide. Then aldehyde is CHO, ketone is C double bond O. Both sides I need to have R on this. We'll see all this now. Alcohol is this. Thioalcohol is this. Amine, ether, double bond, triple bond, halo, and nitro. So all this is what functional group, basic functional, and this is written in the form of their priority order. The first one is most priority, last one is the least priority. So this is how the slide have been made. Okay, now what is an homologous series? See, a series of organic compounds in which all the members can be represented by one general formula is termed as homologous series. Like for alkane, if I want to write general formula, it is what? For alkene, general formula is CnH2 and plus 2. Now, if I'm in this, I'm trying to write n is equal to 1. So if I'm substituting n is equal to 1, I'll get what? CH4. If I'm substituting n is equal to 2, what I get? I get C2H6. Substituting n is equal to 3, I get C3H8. If I'm substituting n is equal to 4, I get C4H10. So I can just keep on moving like this. I can just substitute n for values and I'll be finding out the next particular compound in that particular series. If you try to see here, what is there in this? There is a difference of CH2 in this. Every successive compound will have a difference of CH2. And so you can write as what? There is a difference of CH2 in terms of molecular formula, or you can say that there is a difference of 14 gram or 14 AMU in terms of what? In terms of molecular mass. So that is what is written here. All homologues can be represented by one general formula. Two consecutive homologues will differ by CH2 unit. You can see here CH2 unit. It is therefore it's not only for there for alkene. Like say for alkene, if I want to write C2H2, so the formula for this is what? CnH2n. For which one? For alkene. So for alkene, if I'm writing n is equal to 1, for 1 it is not there. alkene and alkyne start with 2. The reason why, because we can only have double bond with the carbon, triple bond with the carbon or nitrogen or oxygen like that. But hydrogen doesn't form double bond. Double bond is not allowed for hydrogen. Maximum bonds what hydrogen can form is single bond. So that's why we don't get alkene and alkyne when n is equal to 1. From n is equal to 2 we get. So n is equal to 2, if you put, you get it as C2H4. N is equal to 3 if you're putting, so it will be C3H6. N is equal to 3, 4 if you're putting, it will be C4H8. You see the difference from this, and this is also of what? This is also CH2. So everywhere this will be 2 CH2 unit or 14, because carbon is 12 and hydrogen is 2. Sorry, 1 and 1, so 2. So 14. Because 2 hydrogen, right? All homologous can be prepared by some common methods. So all the alkenes, they'll have some common methods of preparation. All the alkenes, they'll have common method. It's not that all the methods what of their preparation will be same, but they'll have few common methods as well. Okay. So we'll go to the nomenclature part. So when I'm talking about naming something, so if I'm talking about naming something, so while you're trying to name an organic compound, there's 3 methods: common names or trivial system. Commonly, like if you have like Chotu, Motu, Chintu, Rinku, all that thing is names. Commonly what people said them, it is used. Derived system, if from where, what is their source? Based on their source, what is did is what we said that this is what will be their name. Then IUPAC system, which is also known as Geneva system. IUPAC is what? International Union of Pure and Applied Chemistry. Starting with common or trivial name, this is CH3OH. Okay, trivial name is what? Wood spirit or methyl spirit. It is obtained from what? A source obtained by destructive distillation of wood. This is urea, obtained from urine. Methane, it's a marsh gas, fire damp, where you'll find mud and all there. From there it is being released. It was produced in marsh places. CH3COH, vinegar, all them have this. Now this have this name for this is what? This is IUPAC name. I'm saying the name for this is methanol. This is urea, because this is an inorganic compound. It doesn't mean that if it contains carbon, nitrogen and hydrogen, it will become an organic compound. No, all the things will not be there like that. Then CH4 is methane, IUPAC name. This is what? CH3COH, acetic acid, first synthesized organic compound. So all these names we'll see as we move further, which will come across. This all is common used things which can be asked in your exam. So I have just tabulated it. Further moving on to this thing, trivial names, we have COH, which is known as oxalic acid, HCOH, which is known as formic acid, obtained from Formicus red ant. Red ant name is Formicus. This is their scientific name. Then this is lactic acid. This one is malic acid, butyric acid, caproic acid. So all this is there. What is there? This all is there in NCERT textbook, or the textbook which is being followed for you as well. So because of this, we are trying to incorporate it here. So that's why we are trying to keep the name here. See, this is compound is marsh gas. The common name is methane. IUPAC name is also methane for this. CH3OH is wood spirit. The common name is methyl alcohol. This is vinegar, common name acetic acid. For this, the name when I'm talking about IUPAC name for this will be what? Ethanoic acid. Will come to that. This is acetone trivial name. This is dimethyl ketone. Acrolein, acryl aldehyde, because you have an aldehyde group present here. This is trivaldehyde. This is pyraldehyde, because it's tertiary valor aldehyde. So you can again find out here is what? This is an aldehyde group. The common names, this and all is there, which is important for you, but you are supposed to remember the common names only when you're done with IUPAC. If you're not done with IUPAC, you're not supposed to go into it. This is what is the name for when I'm talking about the common name. RX is what? It can be RX can be Cl, F, Br, and I. Someone is not on mute, so I can hear that sound. Okay, this is ROS. Thank you. This is ROS. The common name for this is alkyl alcohol, RSH. Because you just read this. Wherever you find out sulfur, you'll find out a word thio. Okay, so this is thioalkyl. This all is for the common name. NH2 alkyl amine. ROR is dialkyl ether. On both sides, I have alkyl group. So if I have methyl, I write dimethyl ether. If I have ethyl, I write dimethyl ether. RSR, dialkyl thioether. See, thio word came by sulfur is there. RCO, dialkyl ketone, because I have, this is ketone group. Dialkylamine, in between amine is there, that's why. Trialkylamine, because I have 3 alkyl group. This is what ROR dash, this is alkyl dash ether, because see R is changing. So this, if I'm writing, like say I have CS3, I have O, then I have C2H5. So C2, based on this, what I write, alkyl dash. So first I'll write this side name, then I'll write this side name, and then I'll write ether. But this will change when I'm writing IUPAC name. So we'll see all that. Talking about the common names. So we have group, atom, or a group of atoms which possesses any free valency are called as groups. Okay, so if there are two structures of same molecular formula, then we can use N, iso, or neo to justify. They'll have same formula, so that we have two structures. Now see here, what is there? We have N-butyl. From where N-butyl came? What we did? We took butane. Butane is CS3, CH2, CH2, CH3. In this, you just took one hydrogen out. So now what is there? One bond is free. So now this became what? This became butyl. The name for this was what? N-butane. From N-butane, you took out one hydrogen. It became what? N-butyl. Propane, you took out one hydrogen. It became N-propyl. Okay. So in this, what is there? This is normal group. We'll write it as N in the present in this. Iso group is when one methyl group is attached to the second last carbon of the straight carbon chain. Okay. So second last carbon. Here also second last carbon. So second last carbon when we have one methyl group present. So that is known as iso group. This is important. Iso thing, neo, secondary, all this is important. So in this, there is an exception. You can see that what is there here. We have no, on the second last, we have still, we are writing this as what? This is second last. Here also it is there. Here also it's there. So normally, if you write octane, octyl stands for what? 8. So octane, you will write it will be what? CS3, CH2, 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 1, 2, 3, 4, 5, 6, 7, 8. 8 stands for octane. So from this one hydrogen, I should have been taken out, or what I have taken is I would have substituted this here, or I would have substituted this on this side. But this is not there. It's only not one methyl group present. I have one methyl group present. This is also second last carbon. This is also second last carbon. So in second last carbon, I have one methyl group, 2 methyl group, 3 methyl group. So this is an exception. Still, this is said in an octyl and isooctyl, and this is also known as isoheptyl. Even being what we have, why we are saying heptyl, because in total we have 7 carbon, 1, 2, 3, 4, 5, 6, 7. Okay, so this is exception. This is important for you. You should remember all this. Okay, exceptions you have to important. If it is suppose what normally iso is, if on the second last carbon we have one methyl group, that is iso group. But what is there here? These are exception. We have multiple methyl group on the second last carbon. Still we are having the name as iso. Now neo group is what? When 2 methyl groups are present on second last carbon. Okay, so second last carbon, if you have 2 CH3 group present, there should be 1 4-degree carbon and at least 3 methyl group on 4-degree carbon. Okay, so that particular, that it should be, there should be 1 4-degree carbon. So 1 4-degree carbon is present, and to that 4-degree carbon there should be minimum 3 methyl groups. So 1 will be there, 2 will be there, 3 will be there. This might go further. So in that case is what we say. We say this. We try to name the name as neo. Optically active thing, you don't have to read about this. This is optically active, which we have that is not needed. There is something known as amyl group. So amyl group is basically same. You are writing, say you wrote CS3, CS2, CS2. Now what you have taken is this when you are having a Same, this is 1, 2, 3, 4, 5 carbon. So 5 carbon is basically if you are writing pentane. So I just write the structure of pentane. Pentane is CH3, CH2, then CH2, then CH2, then CH3. This is what, this is pentane. So what we have done is from this particular thing, I have taken out one bond is free now. This is CH2 and the CH3 have been given to the second, this carbon. So this, I just came up to this carbon, second carbon. So this is known as amide. So what I've done here is this particular group have been satisfied by giving what? N1H and one CH3 group. So now you can see that there is one bond free in this, and to this only directly I have a CH thing attached to. Again here also you have 6 CH. Now to this CH I have 2 carbon attached on both sides. This becomes secondary. Here it was again primary. This is tertiary, this thing. This is again we have 2. So this is again active secondary. So amyl group, you don't get confused. This means that amyl group will be, this will be, amyl is actually not going to come for you, but I have included this because this is there in your portions. The IUPAC name, amyl, we normally teach it, but at present moment, you don't get confused about amyl. Okay, so neo is done, iso is done. Secondary groups are what? The carbon having free valency attached to 2 carbon atoms is known as secondary. So anything, so this is free. This is free for attacking, or something can get attached to this. So to that carbon, if I have 2 carbon attached, so this is known as secondary. Now again, this is also free. So to this 2 carbons are attached, so this is known as secondary carbon. So because we have 1, 2, 3, 4, 5, so it is known as pentyl. We'll see all this now. But this also tertiary means what? To that carbon which is free, where something can get attached, if to that 3 carbons are attached, so that is known as tertiary. Okay, so this is what is iso, neo, tertiary, secondary. Okay, now let's come to alkyl group. Alkyl group, easy. From an alkane, if you take out one H, it will go to alkyl. And CnH2n plus 2 was there, one hydrogen is taken out, so it will be CnH2n plus 1. So from methane, if you take out one H, it is methyl. From methane, you take out one H, it is ethyl. From propane, C, if I have 2 options, I have N-propyl and I have isopropyl. So if I'm taking out one H, I can have these 2 arrangements. This is basically drawing isomers. We'll read drawing isomers in the next class of organic chemistry, where we'll be doing this structural isomerism. So propane, if you want to write, if I want to write propane in this format, I'll write it in this, let's say I can write it as CH3, CH2 and CH3. So this is propane. From this, if I am taking hydrogen, so I can take hydrogen from here. 2 carbons are possible. See, if I'm taking hydrogen from here or from here, it is still same, because it's a CH3 group, CH3 group. So see, if I say that this group is A, so I have only one, I can take out 2 from this, or I have a second carbon which is CH2, so B. So there's 2 possibilities, so I can have 2 such situations. So if I'm taking up from this one, it will become what? If I'm taking out from A, so I'll write it as what? CH3, CH2. From A, if I'm writing, so it will be CH3, CH2, CH2, and one bond is free. So this is what? This is normal propyl, because it's straight chain thing. Now, if I'm doing what is from B, if I'm trying to take out one hydrogen, so it will be what? CH3. I took out one hydrogen, one bond is free. Then I wrote it as CH3. So now if you see, this is what? This is first and this is second carbon. To the second carbon, I have one CH3 attached. I can even write this in this way. There's no problem from writing this in this. On the second last carbon, you have one CH3 attached. From this side, if you come, so this is second. From this side, if you come, this side come. From this side, if you come, this is attached. From this side, if you come, this is attached. So because on the second last carbon, you have one CH3 is attached. So this is why we write it as isopropyl. Same thing for N-butane again. From N-butane also, if you try to do, you can draw that N-butane is what? It is CH3, CH2, then again CH2, again CH3. So what is there? This and this is similar. So one will be taken out from this, and this is similar. So if I'm trying to say this will be A and this will be B. if I'm taking from this, so still it will gives you same compound, so we are not drawing it. Taking from this, still again give you same compound as A, so we are not taking that. So we're taking this, it will be what? CH3, CH2, CH2, and for A, it will be CH2, one bond free. So this is normal because it is on the last. Now, if I'm talking about this thing, say if I'm talking about this one, so I'm taking out from this CH2, CH3. So now see, this is the carbon. Now you have two options. One, what you can say is to the second last carbon, I have CH3 attached. No, if I'm going about to the second last carbon, two CH3 attached, so it is not neo, cancel. Now I'm seeing about this. So this particular thing where the bond is free, this particular carbon where bond is free, to that carbon I have two carbons attached. So that's why it is known as secondary. If because of that, it is known as secondary butyl. Okay. So that's why we have written here N-propyl and secondary butyl, N-propyl and isopropyl. Okay, let's go to the next slide. What we have in the next slide. Okay, further moving with isobutane. If I am having a situation where I have isobutane, so isobutane, first I drew isobutane. From this, if you see in isobutane, this is similar, this is similar, this is similar. So if I'm taking out an H from any of these, this will give me isobutyl. And if I'm taking from this one, from the center one, if I'm trying to take it from this, if I'm trying to make it free, so if I'm trying to make that one free, this will be free bond, and this will be CH3, and this will be CH3. So because this is free bond, this free bond carbon is attached to 1, 2, 3 carbons. So this becomes a 3-degree carbon. So that's why we used word tertiary butyl. Same for that for N-pentane. From N-pentane, which are there? Well, this is there, same. These two are same. And then what we have is this is also CH2 printing metal. This and this and this is same, right? So because of that, we'll try to get. Don't try to get into amine. That is not needed for you. Just try to learn N, iso, neo, normal, secondary, tertiary. Don't, it's not like you do. I'm just trying to skip it. The amyl thing is not there for you. Amyl in for us, like in India, it is being asked for IIT advanced. Okay, same thing from isopentane. If I'm taking from isopentane, see how many are there. This is different. This and this is same. Now this is different and this is different. So basically, I have 3 such situations. Amyl will not try to take. Okay, amyl you don't have to read. So based on that, you'll get tertiary pentyl and isopentyl. From neopentane also you're getting neopentyl. Okay, so this somewhere you're supposed to know because this will help you for drawing the isomer structures. Now after alkyl we have alkenyl. Now alkenyl group for what? From alkene you take out one H, that is alkenyl group. In this we have 2 options. We have vinyl and we have allyl. Now what is vinyl and what is allyl? If the double bond is attached to that carbon whose bond is free, that is directly attached to that carbon, then we say it as vinyl. And if I have the double bond is there to the adjacent carbon to which it have free bond, that is known as allyl carbon. Like for example, if I'm trying to combine here, say here some Cl comes here. Okay, Cl is attaching here. So this will be known as what? Vinyl chloride or vinyl chloride. Why? Because here what is there, that this substituent is attached directly to the doubly bonded carbon. But if I have the allylic situation, so here this will come and it will combine here. So here you can see this is known as what? This is known as allylic chloride. Why this will be known as vinylic and this will be known as allylic chloride. So now vinylic, allylic, why? Because this substituent chloride is attached to which? It is attached to the adjacent carbon, not directly to the doubly bonded carbon. So when it is doubly bonded carbon, it is known as vinylic. If it is directly connected, that is allylic. Okay, so this is isopropyl groups because I have double bond here, so we write it as isopropenyl, which is also known as 1-methyl, 1-ethenyl. Ethenyl because from double bond you are trying to take out one H. There it was alkyl. Here it is alkynyl. If I have from triple bond, you're trying to take out one H. That is, sorry. Excuse me. So alkyne is when you're trying to take out one H from it, that is known as alkynyl. Okay. So this is what is the situation when you're trying. So we have one hydrogen you take from alkane, alkyl, one from alkene, alkynyl, one from alkyne, it is alkynyl. Okay. Okay. Now what we are trying to do is if there is a situation, if I from an alkane, you're trying to take out two hydrogens from the same carbon, that is known as alkylidene. And if you're trying to take out 2H from different, that is known as what? Alkylene. Okay. From the same, from in a case of alkane, if I have alkane and you're trying to take out 2H from the same carbon, so that is alkylidene. This will be written as ethylidene. Ethylidene. Okay. And if I'm trying for alkane, this both is not true for methane. For methane, you can't write methylidene. For methane, you can't write methylene. Okay, it is only true with more than one carbon. That is from methane onwards. Okay. Next is types of ethylene. It is symmetrical and unsymmetrical. In the given two alkyl groups, on one group is attached on the one carbon of ethylene and next on the next carbon. It is symmetrical and unsymmetrical terms are used only when two alkyl groups are given. Like see, this is there. So you have, this is the CH3, this is CH3. This is H, this is H. So you see if you're breaking it from between, so this carbon have H and CH3 balanced, C, CS. So because on both the sides you are getting it in this way, this is known as symmetrical dimethyl ethylene. Why it is symmetrical? Because the groups attached to the carbons on either side are same. But here you say, now on one carbon we have two CH3 attached, on one carbon we have two H attached. So it becomes unsymmetrical thing. This situation where you have carbon on the opposite side, so this thing is later we'll study, this will be known as trans, and if it on the same side, that is known as cis. Okay, so we'll come to that cis and trans later. Not to get confused here. Okay, so we have more examples. Now we have few examples here. Common naming of dihalides. So when two same halogen atoms are attached to same carbon atom, such compounds are known as geminal dihalides. This is known as geminal halides, or we say it as gem dihalides. Okay, like that. Next we have vicinal. We'll see that. So when two same halogens, like if you have this Cl, and from here also you have Cl to this carbon, then you have CH. And it is combined to CH3. So this is known as what? This is known as geminal dihalide. What I'll write it as, this will be gem. Word we write, the word is, the full word is geminal, but we write in the short form, we write gem dichlorides. This is dichlorides. Because I have di-2-chloro, because I have ethane group, so we write it as gem ethane dichlorides, because we have two carbon. Ethane and all we have still not done, so we'll come to that. So see, this is when I'm writing it, I was just telling you from methyl we can't write it as methylidene. It is wrong. We write it as methylene. Okay, so that's what we were talking about, the exceptions. Everything is tabulated. There's nothing which we have to go out of this. We have been now. See, this is, it's not coming here. This is vicinal highlight. The vicinal is which one? When we have the halogen groups. Now see, this is we have a situation where we have this CH2 Cl, CH2 Cl. So this is what? This is vicinal dihalides. That was geminal dihalides. So instead of writing vicinal, we'll many places you just see it as a VIC. So that is vicinal dihalides. Okay. So this is what is the word. If I have iodide here written, so we write it as trimethylene iodide. If I have Br here, and this all is CS2, what we write it as pentamethylene bromide. Okay. common name of dihydroxy again, everything is here. This is butylene glycol. This all is common name. Everything is common name. All these huge things, everything is common name. So anyway, you for what is important for you is only alkyl halides, because alcohol and all is not there for you. You have to just know up to alkyl halides. That was vicinal and geminal. So don't worry. It was only up to geminal and vicinal. Now let's go into the functional group. Let's say if I'm trying to write an IUPAC name. So for IUPAC name, what is there? We have a root word. After root word, we'll have a secondary prefix. We'll have secondary prefix. We'll have primary prefix. And then we have what? We have primary suffix. And then we have secondary suffix. Okay. Both is possible. So now what we do is, primary suffix and then primary suffix. This is how we write an IUPAC name. So for functional group, which is written in this form, that is aldehyde, we use the suffix as aldehyde. Okay. Aldehyde, basically, like for example, I'm writing it as CH3CHO. So this is what, this have 2 carbon present here. So I'll write it as what? I'll write first ethane. I'll drop the last E. I'll write it as ethane aldehyde. Ethanaldehyde. Like that, I have for CX, so we write it as oil chloride, ethanoyl chloride. For example, if I'm writing here this, we'll see one lot of examples after it can use, so don't worry. This will be written as what? Because 2 carbon is there, so it will be written as ethanoyl chloride. Ethanoyl chloride. So like I've just given a name for C double triple bond ion, we write it as nitrile. Okay, COR, it is ending with 8, ethanoate. Okay, functional group for oic acid, it is ic acid. For NH2 attached to this is amide. For ending, this is isonitrile. Okay, this is, I just said you acid anhydride, so we write it as ic anhydride because this is acid as ic acid, so ic anhydride. If 1 carbon, we write it as form. I'm talking about again when we are writing the common name. 2 carbon, it is acid. 3 carbon, prop ion. 4 carbon, we have butyryl. It can have normal butyryl. We have an iso. If you have 5 carbon, we have valid. We use word valid. That is, it can be normal, iso, secondary, tertiary. So you should know this, that if you have 3 carbon and 1 double bond, it is known as acryl. If you have 4 carbon, 1 double bond, that is known as croton. If I have some situations when we say, you would have seen the names as crotonaldehyde. Okay, so this is few examples. Formaldehyde, if I have 1 carbon, 2 carbon, this group, so it is known as acetic acid. You can see here, form, I wrote form, and because aldehyde groups, I wrote aldehyde. I have 2 carbons, so I wrote acid, and because it has acid groups, I wrote it as ic acid, ic acid. And because I have propyne, so I write it as propyne 3, propyne nitrile chloride. All the examples, whatever examples you want, you will find everything here. Okay, this is nomenclature of ester. Nomenclature of ester is done. Examples are done here again. Nomenclature of ester, it is methyl acetate because I have methyl group on this side, and then this is methyl group. This is acetate. So we write it as methyl acetate. In this side, if you say you have 3 carbons, so we write it as propion. One side it is ethyl, so we write it as ethyl propionate. On one side I have what? 2. One side 2. So ethyl acetate. Ethyl for 2, acetate for 2. Again on this side I have 1 carbon, again 1 carbon. So for 1 carbon we have form, common name, so methyl formate. So all the examples you can find here, there will be no doubt if this your understanding, you will understand all the things. Okay, there's a formula of finding out when you're trying to do nomenclature of anhydride. I just told you how to do it. I just told you how to find out the acid, the anhydride thing. Okay, this is derived system. So alkane, alkene, alkyne, from where the structure of group they have found out. So that is example of derived nomenclature. Derived nomenclature you don't have to read. So don't get into that. Common name you have to know, and then you are supposed to know IUPAC norm. So this is IUPAC nomenclature. Let's try to read IUPAC nomenclature. Word root for 1 carbon is meth, for 2 carbon eth, pro for 3. Like this I have taken here. Up to what it is there, 11 is there, 12 is there, 13 is there, then you have 20, which is ecos, 30 is triquant, 40 is tetraquant, 50 is pentaquant. What is important for you? Up to 10 is enough. If you're trying to remember 13, up to that is more than enough. Okay, word root. For word root, we are using this. For suffixes, we are added the root words to show the saturation or unsaturation. If it is a single bond thing, it will be saturation, double bond, triple bond, unsaturation. So that's why for single bond, we wrote in. For double bond, in. Triple bond, ein. If you have 2 double bonds, it's di-in. 2 triple bond, it is di-ein. If you have 1 double bond and 1 triple bond, it is ene. Because for 1 double bond, it is en. For this it is ein. Even though we give priority to ene, but the name ends with ein, so we combining this, we drop this middle e and we write it as enine. So first, unsaturated straight chain hydrocarbons. So unsaturated straight chain hydrocarbon. So for example, I have say what they have taken is CH2 double bond CH CH2. Now you can see what is there in this is. First, I have to find out root word here. So because 4 carbon is there, so root word will be what? Buta. Now I have 2 double bonds, 1 double bond here, 1 double bond here. If I want to do numbering of this, it is 1, 2, 3, 4 carbon. So you can see that on 1 number carbon, and when I'm moving from 1 carbon, number 1 carbon, we have a double bond. When I'm moving from 3 to 4, I have a double bond. So we'll specify the number of it at which the double bond is present. So it is a butane. In butene, what is there? We have the root word at carbon number 1 and 3. I have 2 double bonds, so I write it as diene. Okay. Now next example, what is there? We have to do the numbering part properly. So we'll come to know this. This is there. Then in the same compound, I have triple bond as well. So this is what is the situation. Now you have to think about what here is. I can do a numbering like this. I can do the numbering as 1, 2, 3, 4, 5. Or I can do a numbering in this fashion as 1, 2, 3, 4, 5. Now what you have to see is you have to find out that the multiple bonds, that is double bond and triple bond, they should get the smaller number. So if I'm doing it from this side for this one, so I'm getting the triple bond on number 1 and I'm getting the double bond on number 3. So I write it as 1 plus 3, which comes as 4. And if I'm trying to do for the first one, I'm getting the double bond at 2 and I'm getting a triple bond at 4. So 2 plus 4 is equal to 6. So where I get the smallest number, that particular thing is preferred. So based on that, we'll write the name. Now what I'll do, how many carbons are there? 5. So because of 5, I'll write it as pentene. Now here, why I took out this, whenever you have, when you have double bonds, we try to remove the E. E cell, you can have the doubt is like, okay, I'll just tell you. I'm trying to say. So first what we wrote pent, the root word, because I have 1 double bond and 1 triple bond. So obviously the word have to end with enine. So what I'll write it, I write it as 2-pentene. But when I have a double bond and triple bond, the name has to end with a triple bond, and you're supposed to see that the name is supposed to be ending with triple bond. So what we'll do is we'll give the position in such a way that this is what we'll try. We have to write the name using this. So what we'll do, we'll write the name of the position of double bond before, and then I'll write the position of triple bond. So using that, because on the third one I got this thing, so I'll write it as 3-pent. On third pent I have ene, that is double bond, and then on the first carbon I have triple bond, that is 1-ine. Very important. This have been changed also. They have been changing this as many books. You can find it writing it as pent First, you write the number of double bond. So you write 3. Then you write the number of the first triple bond. Then you write it as E9. But this also is fine. You can see few books writing it as pent 3, but the number of double bond will come first, and then it will go for the triple bond. Over to the next slide. Now IUPAC naming for the groups. Okay, so this all is, we know, if I'm taking out one, so this is methyl, this is ethyl, propyl. Okay, from alkene we took is alkenyl, alkanyl we just saw. This is vinyl, I shown you. Allylic, vinylic, alkenyl is there. All this we have just seen. Okay, so we don't have anything in this to read. Now this is what, this is cyclo compound. So this is what, because this is cycloalkane. So this is cyclopropane. Why cyclopropane? 3 carbons. No double bonds, no triple bonds. So cyclopropane. Cyclobutane. No double bond, no triple bond. 4 carbons. Cyclo compound. So word cyclo and then butane. If 2 hydrogen is replaced, if it is from the same, it is alkylene. If it's from different, alkylene. Already seen. Okay. Okay, so branched hydrocarbon, this is what is important now for us to find out the name when we are trying to find out the branch chain. So 3-methyl, now let's see the structures here, you can see that I have written 2 to 4 here in this thing. Let me draw the structure. CH3, CCH3, then CH2, CH, CH3, CH3, this is CH3. Now what is happening over here? I have to need to number it. 2 probability again. What I can do is I'll be numbering. I have to find out the straightest to biggest chain. So 1, 2, 3, 4, 5. The chain which contains most number of carbon. I did 1, 2, 3, 4, 5. Or the possibilities I write it as ulta. I'll write it in ulta way as I write give this as 1, 2, 3, 4, 5. Again, you have to see the number. So now here, if you are trying to find the sum, on number 2, you have 1 CH3 group plus on number 4, you have 2. So 4 plus 4, this comes equal to 10. If I'm talking about the first one, so I'm getting it on 2 plus 2 plus 4. So 8. Where I'm getting this number less, that is where I have to take it. So this is what will be the correct name. Using that, if I'm trying to write it, how I'll write is, see, on the second carbon, we have 2 methyl group, and on the fourth carbon, we have 1 methyl group. So I'll write it as 2, 2, 4, tri, because I have 3 methyl group. Trimethyl, I'll write, because in the main chain, I have 5 carbons, so it is known as pentane. This is what will be your. So we have rules for branched hydrocarbons, how you try to do it. Unsaturated branched carbon, cycloalkanes. Okay, everything what we read. Now there are organic compounds which is only used as prefix. Okay, there are functional groups. These are the functional groups like halo. So there inter fluoro, chloro, bromo, ido. All these are only used as prefix. NO2 only as prefix. They will not be used as suffix, but the name will not end from that. Okay, these are not, or you can even say that those groups from which the name of the compounds end, those are known as what? Terminal functional group. Those are known as terminal functional group. Okay, so here you can see there is no such thing. These groups can only form the prefix. Okay, so like for example, you have examples over here. We have taken few examples like CH3, CH, CH2, CH3. This is 5 carbon, and to this, if I have chlorine and bromine attached, so I have to see what I have to just write. This can be used only as chloro and bromo. So what I'll write it as, the name here will be written as what? We'll just write. So we'll write it as 1 bromo. Will be written here as what? 1 bromo, and then I have 5 chloro. Before in alphabetical order, before B comes and then next C comes. So what I'll write here the name as 1 bromo. At 1 we have 1 bromo. At 5 I have 1 chloro. So at 5 I'll write chloro, and because in the main chain I have 5 carbon, there's no double bond, so I'll write it as pentane. So 1 bromo, 5 chloro, because B comes C before C, so we write it as 1 bromo, 5 chloro, pentane. Like that only in this example, on the second carbon we have fluorine, so we write it as 2-fluoropentane. On the, when trying to give the number, on priority will be given to fluorine, so 1, 2, 3, 4, 5, 6, 7. So on fifth carbon we have chlorine group, so I write 4, 5 chloro. On the second carbon 2 fluoro. The numbering will be given priority to the fluorine, not in the writing, because C comes before F. So first C will be written in this. For this also same, if I'm trying to do numbering it, I think so it will be in this. No, it will be in ulta fashion because the longest chain will come. Okay, so longest chain will come, so it will be 1, 2, 3, 4, 5, 6, 7. Okay. It's 3. So in this third we have chloro, on fifth we have fluoro. Based on that, because we have 7 carbons, so heptane. Okay, this is something which is new. Epoxides are basically, this group is epoxide, this O. So when you have to find out on the numbering what will be there, this will be 1, 2, 3. So on carbon number 1, with carbon number 1 and 2, we have oxygen attached. So we write it as 1, 2 epoxy. Total we have 3 carbon, because of that propane. If you come with here, you can see, if you remember it, it will be what, 1, 2, 3, 4. On carbon number 3 and 4, carbon number 3 and 4, we have O attached, so we write it as 3, 4 epoxy, 7, so heptane. Okay, so case 2, where the things can be used as suffix as well as prefix. So functional group COOH, carboxylic acid, it can only be used as, so this oic acid came here, this will be only used here, oic acid. Sulfonic acid, name is sulfonic acid, suffix will be sulfonic acid, prefix will be sulfur, and they're trying to used as prefix. So sulfur. Like that only we have for acid anhydride. This all has been tabulated. Okay, this all is the tables for them. So the rule for the nomenclature, the basic rule for the nomenclature is what? Selection of the carbon chains, longest possible chain we try to find out. Then when we are trying to do, now this actual, all the rules will be included here. So the first rule is what? Longest possible carbon chain with functional group and having maximum number of multiple bonds is selected as a parent carbon chain. I have to see that it should be the longest possible carbon chain. It should contain the functional group. It should possibly how many multiple bonds, that is double bond and triple bond, it can contain. That you have to take. Numbering all is what we'll do. The first priority to the number will be functional group. Then it will come multiple bonds. Then it will come to substituent. We'll see the examples now, so don't worry. If a chain ending carbon containing functional group is present and numbering starts from C of the functional group, this functional group is known as Dawn category functional group. This category is basically shown here. This is COH. This all will be term. This all is Dawn basically means what? This is terminal groups. This is terminal groups, means the name of these things have to end with this. Terminal groups. This. You can see example, rule number 3, E of primary suffix is dropped off if secondary suffix starts from a vowel. Example here, you can see here, this is what? This is 4 carbon. So we'll write it as what? Butane. And because it is ending with the group present here is oic acid. So I write it as butanoic acid. But because this is O is the vowel, A, E, I, O, U, these are vowels. So because O is there, so this E will be dropped and the name will be written as butanoic acid. Same thing for this butane. Now here also methanamide is written. Why methanamide? Because methane group is there. One carbon is there, so the name should have been like METHA, methanamide. But because I have A here, so this E will be dropped and the name will be written as methanamide. Okay, so vowel wherever you see, you find out this. Next, esters. ester's name will be alkanoid. You have to be very clear in this. Now see, they'll be written in this fashion. So after O, whichever is there, that will be going alkyl, and others will go as alkanoid. Okay, so the name is written as alkyl alkanoid. The C example CS3 C double bond O CS3. After O, whatever is there will go as alkyl. So it went to alkyl methyl, and this 2 is there. It will go as ethanoid because 2 carbon is ethane, and the ester ends with O8. Here also you see after O, whatever is there, after O, this is there. It goes as ethyl. After this is 1 carbon, so methanoate. Okay. And hydride nomenclature is based on from where it is obtained. So if I have, it is obtained from this 2, so we write it as ethanoic anhydride because both are ethanoic acid. If I have 2 things, I write, if I have say ethanoic and methanoic acid, so I'll write it as ethanoic methanoic anhydride. Okay, so you can see the example. We have ethanoic propanoic anhydride here. How I get to know this is we have 2 carbon here and have 3 carbon here. Okay, so that means it came from ethanoic and it came from propanoic. Okay, and you can find it also when you're trying to do hydrolysis of it, because when you take out H2O, you get this. Okay, so when you give H2O, you'll get back from where it have been. So you get it this. So this is propane. From here you see now this is what butane dioic anhydride, because I'm getting what is this. I have 2 OIC here, 1 2 1 2. Okay. So I'm numbering this in this fashion. Okay. Now we have another things how you're trying to go for amines and all. If you have multiple polyfunctional group. Polyfunctional groups basically means what is there in the same carbon. I have HS also, this is also a group, and we have COH also as a group. So this all is what this is for polyfunctional group. So for polyfunctional group, we are supposed to know about the priority order. Now when I have here what is there, 1 COH is there, OH is there, NH2 is there, all these are functional group. I'm supposed to decide from which I'm supposed to end the name. I need to give priority that time. So based on this priority list, we have to decide that yeah, this is what will be from this, the name will be ending. Okay, this is according to the priority list. Fine. So COH gets priority more than OH and NH2. So this all others will get. So for example, if I'm writing this COH, H, OH, C, NH2, H. Now see on the both side I have COH. So if I start from any side, it will get 1 and 1. Now the thing is you have to decide from which side among OH and NH2. We just now read that NH2 and if we go to the first table, we had the priority order for COH come, then OH will come, then NH2 will come. So I'll start giving the numbering. So 1 CO, then OH, then 3, then 4. So I'm trying, because only one functional group will be there priority wise, the name will end with COH. So for this, what I'll write, because on the 3rd carbon we have amino groups, I write 3 amino. Then on 2nd we have hydroxy, so we write 2 hydroxy, 2 hydroxy. Then I have 4 carbons, so for that I'll write butane. And on carbon number 1 and 4 we have 8, so I have 1 4 dioic acid. Now if you see here clearly, because I have D over here, I have not removed this E. If I would have written as oic acid, I would have removed this E. So options, you need to be very clean when you're taking option. Because I have not removed this E, reason is what? Because I have D over here. Okay. Now when I'm talking about if any carbon containing functional group is present as secondary functional group, okay, then its carbon is not included in the principal carbon chain except CHO. Okay, except CHO, like for OH, for CNC. Now see, I have here two options. I have this one, this is COH. One is, this is a main functional group, priority order, COH is very high compared to NC. So two functional group is there. Though here one carbon is present, what the rule says, except CHO, this carbon will not be counted when you're writing the root word. So only these three carbons will be counted as a root word. On the third carbon, if I do numbering, on the third carbon, we have NC group. So we write NC for the prefix, we write it as 3-cyno. Because I have three carbons, so we write it as propanoic acid. Here also same thing, we have which one? We have, this is one functional group. This is another functional group. Priority was, this will be given number. So I can't count the carbon here. I'll just write 1, 2, 3, this carbon is counted. So at third carbon, we have what? Carbonyl, chloro, and this is carbonyl group. So I write it as 3-chlorocarbonyl. Because main chain we have 3 carbons, so we write as propane. Because OIC, see, I dropped E here because it's directly connected to OIC. If dioic would have been there, I would have written E. Okay, as secondary functional group, if C of CHO group is included in parent chain, then the oxo is used as prefix. Otherwise, we use forminyl group as prefix. Okay, now see, I have here what? We have COOH group. And here we have aldehyde group. Now what we said just now, we read what is, except CHO, we can't count the carbon. So now because I'm counting this carbon, the main chain, like from numbering, I'll write it as 1, 2, 3, 4. So because I counted this carbon in the main chain, so this will become what? The prefix. So what we write it as, on fourth group, I have oxo, or I can also write it as 4-formyl. 4 carbons, so butane oic acid, so butanoic acid. So for this again, we are trying to number it again. So we have what here? On 2 we have formyl, and then we have butanamide. Okay. On 1 and 4 we have butanamide. It will end with this because this will be getting more priority when it is compared to this. So this will be numbered 1. So I'll try to number it in that form. So I'll write it as 1, 2, 3, 4, or if I'm numbering it, will be numbering from this side 1, 2, 3, 4, because second number you'll get this side. From this side, the aldehyde will get third number. From this side, the aldehyde is getting second number. Where it get the smallest number, we'll try to go with that. So on second, we have formyl, 4 carbon butane, 1,4-diamide. Because see, again we had di here, so we are using E. Next, ClCO, so again aldehyde, 3-dioxo pentanoyl chloride. So how basically how we are supposed to use this? We have this thing. The IUPAC nomenclature of carbon containing category functional group is present as a principal functional group, and its C cannot be included as the parent chain. Okay. Now see, if I'm talking about this thing, I can't include this in the chain. I can either write this or this. So what I can write this sense. I wrote this one as what? Cyclohexane, because cyclo compound 6 carbons, so for 6 carbons cyclohexane. This cannot be included. In that case, I write it as directly carboxylic acid. Same thing here, benzene carboxylic acid, because I'm not able to attach. So for that we have name. When you're not able to count these carbons in the principal chain of COH, it is carboxylic acid. For anhydride, it is carboxylic anhydride. For COR group, it is carboxylate ester group, basically CO. This is oil chloride, so carbonyl chloride. Amide, carboxamide. CN is carbon nitrile, or we say it as carnitrile. CHO is carbaldehyde. So this is when you're not able to count. For example, say if I have some situation like this, and we have this. This is CH2, CH, and CH, sorry, CH2. How I'll name this? Which you'll give priority, which you'll not give priority. All are same groups. All are same groups. Which you'll give priority, which one you'll not give priority. Okay. So in this case is what I'll try to write it. I'll write this as propane, because 3 carbon. I'll count all this thing outside the chain. So propane 1, 2, 3 tri carboxylic acid, because on 3 we have carboxylic. Like this, we'll try to write the name for this. Okay, so nomenclature of some cyclic compounds with functional group. You can see this is cyclohexanol. Because we have cyclone, we have functional group as alcohol. For alcohol ends with ol, so hexanol. This is again our third. This is terminal group, so this is methyl here. So I'll start numbering. Functional group will be giving the first number, then 1, 2, 3. Third, we have methyl cyclohexanol. Again, in this, it is because halo groups can only be used as a prefix. So we write it as chloro and benzene. I don't have to mention number because only one substituent is there. Here also you see, I'm not able to count that this carbon I'm not able to count here. So what I'll write here is, I'll write for this is cyclohexane, and this is CH2, that is carbaldehyde. Now this is what? This is cyclohexane. This is carboxylic acid. So we write it as cyclohexane, carboxylic acid. Because I'm not able to count these carbons. Here this carbon is not being counted. This carbon is not being counted. Because of that, here I write it as carbaldehyde. Here it is written as carboxylic acid. Okay. Now nomenclature of few aromatic compounds. There's no rules for this. Okay, there's no rules for having nomenclature for some aromatic compounds. There's no rules for this. What we have here is we have common name for most of the aromatic compounds which are accepted by IUPAC. Okay, so this is like this is benzene. This is benzenol, which is also known as phenol. This is IUPAC name. The bracket ones are your IUPAC name. So this is phenol. This is benzene. Benzene ring is there, and then amine is attached. So we write it as benzenamine. This is aniline. This is known as nitrobenzene. This is benzene carbaldehyde because benzene ring and CHO, this cannot be counted inside. So I write it as carbaldehyde. Common, the IUPAC name for this is what? Benzaldehyde. Now this is benzene carboxylic acid because benzene ring carboxylic acid group. So I write it as benzene carboxylic acid. Together we say it as benzoic acid. Here benzene and carbonyl chloride, this is carbonyl chloride. So why we write benzene carbonyl chloride, we write it as benzoyl chloride. Now we have methyl group here. This is benzene, so we write it as methyl benzene, which is known as toluene. This is known as, no, see, this is this wherever you have a functional group, substitute the main functional group. Next to that position is known as ortho position. Next to that is known as meta position, and next to that is known as para position. So we have ortho, meta, para. You can see on ortho position we have CH3. So we are writing it as orthocresol. This is 2-methylphenol, but the IUPAC name is orthocresol. Here because it is substituted in meta position, it is metacresol. Here it is substituted as para position. So this is para position. So it is known as paracresol. When I have CH3 attached here, this is known as orthoxylene. If it is here, then it will be known as metaxylene. If it is here, then it will be known as paraxylene. This all is aromatic compound. Aromatic compounds are those compounds which have some characteristic smell. More example on aromatic compounds. In this and 2, which is priority, this is first, so 1 and 2. Based on this, on second we have hydroxy group, so I wrote 2-hydroxy group. This is benzoic acid, I wrote benzoic acid. This is IUPAC name is what? Salicylic acid. Okay. Next one is, because in this and this, which will be given priority, this is given priority, so this will be used as substituent. This one will be used as substituent. Based on that, if you write the name, it will be what? On second group, 1, 2. On second group, we have hydroxy. Because we have aldehyde group, so we write benzene on that aldehyde, so benzaldehyde, which is also known as salicyldehyde. This is the COH group. So this is M-isothallic acid, and this is para-terpethalic acid. Okay, so we write it as normally phthalic acid, phthalic, or it is known as benzene 1,2 dicarboxylic acid, because you can write purity as anyone. No? This both the same. So 1,2. So benzene 1,2 dicarboxylic acid. IUPAC name. This is IUPAC name. Okay. So this will be priority at that time. So this will be given as 1, 2, 3, 4, 5, 6. So which position we have nitro group? On the second position, on the fourth position, or on the sixth position. So 2, 4, 6 trinitrophenol, which is also known as picric acid. This is again same thing on group number 1, 2, 3. Position number 1 on 3 we have alcohol group. So benzene 1,3-diol, which is known as resorcinol. Okay. Further, when I'm talking about this thing, this will be given. We'll try to count the names. So this is there. What is, I have one group here. This is so 1, 2, 3, 4. Then we have what? This is basically, if you remember, when you are trying to write alkyl ethanoate, this will be written first. So that's why this side I have methyl. So I write methyl first. And then fourth, I have hydroxy. I write 4-hydroxy. And then because this is benzene ring and this is what, this full will be counted as. So it will be written as benzenoate, or we write it as benzoate. 1, 2, 3, 4, and fourth we have hydroxy. Okay, so this is for this methyl. If I have C2H5 here, ethyl will come. If I have C3H7, there I have propyl. So like this, the names will be there. Okay, further. Okay, next is, you can see benzene sulfonic acid is there. If this is sulfonic group, and in this and this, if I have to give priority, this will be again first priority. So 1, 2, 3, 4. On fourth, we have sulfur group. So 4-sulfur benzoic acid. This if I have 2, so I can't give priority here now because both are same group. I write it at 1 at 4. I have benzene disulfonic acid because I have 2 such groups. So I write it as disulfonic acid. Further, we have already seen this, that this is vinyl and this is allyl. If I'm using it, so this is phenol. Okay, phenyl is also written as this. This both is, so you can write it in this fashion. Okay, this all is used for same thing, phenyl. Okay, this all is phenyl. This is benzyl. This is benzol. This is benzo. Okay, CH2 1 bond free benzyl. CH2 free benzyl. C3 free benzo. If I have a group here G attached, this is known as aryl group. Anything it can be. This I have CH3, CH2. It is orthotolulyl, metatolulyl, and paratolulyl. This is basic. Whatever we talk about is this is the basic your IUPAC nomenclature. Let's try to solve few questions so that we'll get an idea about this thing. And further, we'll see what all is there. Let's try questions. So first question is COOH, CH here, then COH, and then COH here. What is the name for this? Try. One trimethanoic acid. Okay, but we are not able to number this, right? saying here, this is one. We're saying that on the first carbon, don't you think the name should be this? Methane 1, to 2, 3, according to you. I'm just trying to say. If I'm writing it like this, but I'm not able to count the carbon of this. No, if I'm not able to count the carbon of this thing, then the answer cannot be in this fashion, right? Answer should be in this way, that we have methane. Methane is there. Then on one same, sorry, this will be 111. On same carbon, we have 111. As we are not able to count it, we'll write it as tricarboxylic acid. When we are not able to count it, we write it as carboxylic acid. When we are able to count, then all this kind of naming comes. Okay. Try this. We have CHO, then CH2, CH2, CH, CH2, CHO, CH2, CHO. Okay. Fine. So now the name for this, yeah, I have again this thing, this thing, this thing. I can't neglect anyone. But what we do is, if you remember, what we can do, we can count out the carbon of an aldehyde. So if I'm trying to go in this direction, so what I can do is I can't give priority to any of this. I'm just trying to find out the longest chain. So I go in this fashion, or I go to 1, 2, 3, 4. In any fashion, I get this 4. Now I can write here as on the third carbon, we have formyl methyl. We can write it as oxomethyl as well, because I'm not able to count it in the main chain. So I write it as on third, I have formyl methyl. After that, I have total how many carbons? Total I have how many? 4. If I'm writing it in this case, so what I'll do is I can write it in this fashion, that I'll write it this, and I can count this carbon. So the one carbon which is not being counted, I'll write it as prefix, and others will be suffix. So 3-formyl methyl hexane 1, 3 diol. Okay. Let's try this. First question, CH3, CH2, CH, COO, C2H5, CH3. Name for this.
let's see. If I'll start numbering for this one. So what I'll do is I have to find out the longest chain. If you can see, the group here is what I have ester group here. So I'm trying to write down the ester group. So ester group, I'll try to do the numbering. So we'll try to do the numbering. This is because this is what ethyl. Okay, so you remember COH, whatever we write it in this fashion. And then with O, whichever is there. So this will be taken as your prefix. I wrote ethyl. Okay, that is first thing. After that, we should start numbering. I'll write it as 1, 2, 3, 4. So on second carbon, if you see, I have methyl group. So I write it on second, we have methyl. After writing second, I have how many carbons? 4 are there. So I write it as butanoate. This is how the ester is written as what? Ester is written as alkyl alkanoate. Let's see the next question. The question is N triple bond C CH2 and triple bond C CH2 CH2OH. Try this.
Two cyanoethanol.
Two cyanoethanol. On second group, on which group? The C. This carbon I can't count. If you remember, as a rule, except CHO, I can't count CN. So C of this carbon will not be countable. So according to that, what will be the name? Can I write it in this fashion? 1, 2. Okay. 1, 2. So, or if I'm trying, according to the priority order, I need to give priority to OH, to CN, right? So this will be written as 1, 2. So I write it as 2 hydroxy. On second, we have hydroxy group. On second, we are supposed to have hydroxy group, and then we have 2 carbons. For 2 carbons, we'll write it as what? Ethyl. For 2 carbon, we'll write it as ethyl, right? So 3, so we can write it as, I'm counting it, 3 carbons. So 3 carbon, I'll write it as propane and propane nitride. This is one option. If I'm trying to count everything, if I'm counting this one also, then if I'm writing the name in this fashion, then I'm writing, if it is 1, 2, 3, then I'll write it as 3 hydroxy. On third, I have hydroxy group and then propane nitride. Because I'm able to count this, because in case, say, if the same question was there in this way, same question was there with the COOH. So in this case, this doesn't come before COH in priority order. In the case of OH and CN comes before OH. So we have been counting this. If this is not able to be counted in the principal chain, so that time this carbon will not be counted. We write it as 1, 2, 3. So this, what we'll write it as 3 cyano. And third, we have cyano group, and then 3 carbons. So it is propanoic acid. So understand the difference when you have this kind of situation. Then we have to check that it is there which functional group. According to the priority order, CN comes before OH. So when it is there in the principal chain, that time the carbon will be counted. But when in the case where it will not be in the principal chain, so the carbon is not being counted, and it is taken as a prefix itself.
Okay, let's try next. Next question is CH3, CH2, CH, CHO, CH, CHO, CH, CH3, and CH3. Write your answers in the chat box. CH3, CH2, CCH, CH3. If I'm trying to write the things from here, so see, this is my functional group. 2-methyl pentane 3-al. Possible. Let's see. See if I have to give here is this is the number. So 1, 2, 3, 4. Don't have any other functional group. So if I go like this, also I get 1, 2, 3, 4, 1, 2. So longest chain possible is a 4 chain, right? If I'm trying to neglect this thing, if I'm trying to get priority to which one, to the longest chain only, to the longest chain only. So in that case, what I can do is, if I start numbering from this side, I write it as 1, 2, 3. So still there is no changes. I can't get anything more than this, right? I can't get anything more than number 2. So I'll go in this order. I write it as 1, 2, 3, 4. So what I can write is at third we have 3-methyl. Before that 3-methyl, I have this. At second carbon, I'll have ethyl. So 2-ethyl, because this ethyl group is also present. This is also present at substituent. So 2-ethyl, 3-methyl. For 4 carbon, it is butane. So butane 1, so butane 1L. This should be the answer. There are a few basic questions. 1, 2, 8. Okay, take this CH3, CH, Br, CH, Br, CH2, C double bond OOH. Number 2, the first one, then we'll go to the, or you can take is 1. Okay, for this, if I want to number, it will be 1, 2, 3, 4. So I can write this as 3 bromo. On third, we have bromo group. So 3 bromo, butanoic acid. Okay. For this one, if I want to number, so this will be 1, 2, 3, 4, 5, 6. So I can write it as what? On 3, I have ethyl. On 3, I have ethyl. For 6, hexane. And because we have this, so we write it as hexane 1 O. Because we have O, so we took out the last E. Next questions can be Br, CH, Cl, CH, Cl, CH3. This is easy. CH3, CH, Cl, CH2OH. Number 3, you can take it as CH3, C, CH2, CH3, then CH2, CH3, right? One more you take. Number 4 is C double bond O, CH2, CH2, CH, CH3, and CH will have an H2. You can write their name in the chat box. Okay, for this, if you want to number, so 1, 2, 3. First one is 3 bromo 2,3 dichloropropane. Okay. See, if you are writing in this fashion, if you're writing 1, 2, 3, then this, okay. You have written it in this fashion 1, 2, 3. But if you add this thing, it will be 1 plus 2 plus 3. And here, if you try to add it, it will be 1 plus 2 plus 3. Okay. So no changes when you're talking about these things. You can write it in any way. Okay. So that's no problem. You write. This is fine. So if you're writing it as this will be what? 3 bromo and 2 comma 3. 3 bromo 2 comma 3 propane. dichloropropane. So 2,3 dichloropropane. So Nilvanari's first one is right, chloropropane. Second one is 2-chloro-3-hydroxypropane. Now both of them you can't take it as the this thing. You have to give one as the last functional group. So you write it as this is fine, 1, 2, 3. So you'll write it as 2-chloro. That is correct. But because if you're taking one as a prefix, other has to be suffix. So 2-chloro, you write it as propane, 1 all, because it's this thing. Next one is if you're writing 2-ethyl, 2-methyl butane. First, try to find out the longest chain. So if you try to find out longest chain, it will be 1, 2, 3, 4, 5. So I can write it as what? If I'm trying to go it like this, what will be there? 1, 2, 3. So in either case, it is 1, 2, 3. So I am getting what? 3, 3 dimethyl, 3, 3 dimethyl. Because I have 5, so I write it as pentane. This one, if I want to write, I'll give priority to this. So 1, 2, 3, 4, 5. So 4 amino pentanol. Okay, so these are few basic names. We'll still continue with organic chemistry in our next chemistry session. We'll be doing more questions related to IUPAC. So if you have to, you can revise the basic rules to be ready for that. We will move with the further 4 amino pentan. Pentanoic, no, this is only CHO, aldehyde group. Aldehyde group, why you are giving the name of COH? This is acid. What is different? Acid is this. This is acid. This is aldehyde group. Okay. Anyway, good. People, you all started trying, so that is good. More what matters, you should try. That's what is mattering more. Okay. Fine. So this is what we had for today. We'll see you at the next class. Thank you.